Bismillahir Rahmanir Rahim. Assalamu alaikum. In this lecture, I will describe how can we design a PCB starting from a schematic. We will start from the very schematic that we have already drawn in the last lecture. So first of all, go to Files, choose PCB Board Wizard. So in this wizard, we will follow some few steps. First, we have to choose between two unit system. Imperial unit system means inches and mils. Metric unit system means millimeter and centimeter. So we choose imperial. Next, and now we can choose either custom size board or predefined sized board. So there are some predefined sizes of the board: A size, A0, A1 sizes, and some other sizes as well. So we will choose custom. We can have either rectangular or circular or custom shape board. So we will choose rectangular, and the board size we can choose a small size of board because we have a small number of components in our schematic. So we hope that the size a small size PCB will be sufficient to house the small number of components that we have in our schematic. So let's say width is 3 inch and height is 2 inch. And next, signal layers and power planes. In multi-layer PCBs, normally we can have number of power planes. For example, if there are 4 layers in a PCB, we can define that 2 of them are signal layers, 2 of them are for signal tracks, and the remaining 2 are for power planes. Power planes means they are for power tracks, the tracks for VCC and ground. So we can just make it 0. So we don't have any power planes, separate power planes, although we will have VCC and ground tracks, but not a dedicated layer for VCC and ground tracks. And we can choose through-hole vias, since we have normally through-hole components only. So, and we like to pass a single track between the adjacent pads of a component. And for the time being, we can go with the minimum track size and via and minimum clearance as they are in this. So now finish, and this will create a new PCB document for us. And we can see here that the size of the PCB is actually 2.9 inch. In fact, it is 3 inch because 50.05 inch is left here. So in fact, from edge to edge, the PCB width is 3000 mils. But this pink color lines are shown. This pink color line is actually the keep out boundary. This boundary tells us that we can place our components and tracks in this within this boundary. So if we try to place our components or tracks near to this boundary or outside this boundary, this will not allow us. So now we like to load the components from the schematic. So we go to design, import changes from first of all, we need to save this PCB document. So we save it. Yes, save. So we save it here. This is the same folder in which all other documents have been placed. so we can save it, and we can also rename the PCB document. For example, we can save it as display 1. Okay, and in the second step, we also need to include this PCB document into the project. So we need to add this document to the project. So add existing to the project. Display 1 is added to the project. Now now display 1.pcb document is the part of the project. And first of all, we save the project. Okay, now we can load the components, design, import changes from the first underscore project. So all the components that were there in the schematic will be loaded here. But here it has been mentioned that a footprint not found. Which footprint? The footprint of U3 is not found. So without executing the changes, close this one and go back to the schematic, and let's sort out the problem. So U3 is this one. This is the U3, and this is the component manufactured by Fairchild Semiconductors. So we need to see whether the library of this component is available in the set of libraries or not. So the tab of libraries is not visible here. So let's see here, view and workspace panels, system and libraries. So make the libraries visible. So now we can see here that the libraries available in Altium do not include the library holding this component. This is the counter IC, Fairchild Semiconductor counter IC. So there is no counters, library of counters of Fairchild Semiconductor. So we need to install this library. So we go to libraries, install, and Fairchild Semiconductor. So this is Fairchild Semiconductor, and we need to find the counters library of Fairchild Semiconductor. If we are unable to find, we can search here, counter. So if this is Fairchild Semiconductor logic counter library, now the library is installed, close. Okay, now the library is available, and let's try again, design, import changes, validate. Okay, now the all the changes are validated, and now we can execute changes. But before that, we also need to look whether all the footprints of the components are according to our desire. For example, I think this component is so the footprint of this component is SOIC, which is the footprint of surface mount component. If it is according to our desire, we can leave it as it is. But if we like to replace this footprint with a through hole footprint, so then we need to replace this component. So this component is available in Fairchild Semiconductor library. So we can see here that with this name 74LS90, we have two of them. One is 90M. The footprint of 90M is visible here, which is a surface mount component. But 90N is a through hole component. The footprint is a through hole. So we need to replace this component. So we place this component here. and we remove this component and we place new component here, and we also need to make the designator of this as U3 as U3 was the designator of the component that we have removed recently. So now again we load the components. Again we validate changes. All the changes have been validated, and now we execute the changes. When we execute the changes, we have components here, so we can place all these components here in within the region of the PCB. So we have placed here. Now we can see that the size of the PCB that we have defined is more than necessary, so we can change the dimension of the PCB. We can change the size of the PCB. First of all, you must know that when I move the mouse, the current location of the mouse is shown on the lower left corner of the screen. Here you can see here the X and Y coordinates of the point where the mouse is located. So the coordinates of this corner of this PCB is actually 2000 comma 3000, and similarly the coordinates of this point are 2000 comma 5000. So X coordinate is same, Y coordinates are different. The coordinates of the lower point is 3000 and the upper point is 5000. So the height of the PCB is 2000 mils or 2 inch. So if we want to make the height of the PCB as 1.5 inch, for example, so then we can design board shape and move board vertices. So we can just move the board vertices, and its new location, we can select the new location either with mouse or the down arrow of the keyboard. So I'm using down arrow. So this is the new location of the vertex. Similarly, we can relocate this vertex. So now the dimensions of the PCBs have been changed. This is the new size of the PCB. It seems appropriate because it is according to the requirement. So now we also need to relocate this keep out boundary. So we can just design board shape, create primitives from board shape, keep out layer. So now the keep out layer has been relocated. Now the keep out boundary is exactly at the mechanical boundary of the PCB. Normally we want to make this keep out boundary away from the mechanical boundary of the PCB. So we can shift this boundary slightly into the PCB. So we can move it with the left arrow. I moved it towards right. I moved it 50 mils towards right, and similarly we can move with this boundary 50 mils up. You can see at the lower left corner how much I've moved. Similarly, this one, and similarly this one. Now I've moved the keep out boundary as according to the requirement. So now I can also resize the room definition. This is the room definition. Room definition is the area, is the region in which we can place our components. So now we can place our components anywhere in this room definition. This is U3 if I like to rotate this component, because this is the pin number 1 of U3 and this is the pin number 1 of U4. If I like to rotate so that it is placed in this way, its pin number 1 is on the upper side. Similarly, I can also rotate this component. Now we can place all the components as we desire. Here the holes are not visible, holes within the pads, so we can just make them visible. Pad holes, show pad holes. So now we can see that there are the pad holes are visible. So if we now like to connect any two pads, so we can just place tracks. For placing tracks, we press P, and then interactive routing. For interactive routing, we can press T. So interactive routing means only those connections can be made that are allowable. Which are the connections that are allowed by the software? The connections which are defined in our schematic, that are only allowed connections. So for example, we can see here that this pin, this pad is a part of the net C2_2. So we can connect this pad with this is the bottom layer. We are on bottom layer, therefore the color of the track is blue. So if we like to have tracks on top layer, we can also select top layer from here. So then we can place track on top layer. Let's see here PT again, and now the track is on red color because we are on a top layer. So we just delete this track because we don't want to have any top layer track. So now I will connect a VCC. For example, now this we connect this VCC P T. Sorry, again bottom layer PT. So now important thing is that you must notice that many of the pads have been faded, but only few pads are bright in color. The pads bright in color are actually the pads that are connected to this VCC net. So this wire, this line is actually showing me that this pad can be connected with this pad. So let us connect. Now you must notice that if I like to connect this VCC track with this one, of course this is not going to connect. It is not allowable because this is the this pad is connected to ground net. So we can only connect this VCC net with this pad, because this pad is a part of VCC net, so we can connect this. Similarly, if we like to connect this ground net, this ground, so we can place another track, and now where it can be connected. So the lines are showing me that this can be connected to here. Now these two pads have been connected. Now we can connect all the tracks one by one. Now it's your job to connect all of the pads with each other. Now to make the routing more efficient, you probably need to move components in some other appropriate locations. So for this lecture, that's it. If you have any questions regarding this lecture, if you face any problem in any of the steps in designing or routing PCBs, you can post your questions. Thank you. Allah Hafiz.